set the port on which the frame arrives. Right? That is number C. Is there any question for question 10? Is there any question? Can you hear me clearly? Okay, that is the C. 11. Self-learning suite never. Which following statements are true about self-learning suite? Choose 3. The self-learning suite never forget. This is wrong, right? Number 8 is wrong. Self-learning suite associated with the source MAC address on an incoming frame with the port on its arrive. It says it's true. So it's when it received the suite receive the frame on one port, then it's associated the MAC address, particularly the source MAC address with the port. Okay, the self-learning suite, which HR forget the self-learning association, so it have time to leave. Right, so the association is have a period. If doesn't use for a period, then just forget the mapping. So self-learning suite free the network manager from the at least one configuration task that might be associated. So it's just self-learning, right? We don't need to the administrator doesn't need to configure the suite, right? The suite doesn't need the configuration. Is that clear? Any question? Yeah. Number 12. Consider a simple star connection below. Should table is initially empty. Okay. Suppose C send an internet frame to C prime and C prime replies back to C. So C send, this is the source and this is the destination, right? How many of these two frames are also received at B interface? So how many of these two frames is receiving at the at B interface? So first step, C sending to suite, and the second step suite flooding the frame, right? So B receive 1, right? So it's a B, right? B also flooding the frame to on the port, then B receive this frame. And the third, C prime and the suite and the suite recall the mapping C and 3. C mapping with the port number 3, right? Suite plot in the frame and C prime respond, right? And then the suite recall the mapping C prime and port number 6, right? And then the response frame is forward to the port number 3. Forward is forward to port number 3, right? Respond to B. So B just receive only one. B just receive only one frame, right? During this process, right? Is that correct? Is that clear? Right? So during the sending and receiving the response, then we only receive one frame during that process, right? Any question? Yeah. Consider simple star connected Ethernet LAN shown below, and suppose the table contain the entries for each of these hosts. So now the suite contain the entries for all six hosts. How will those entries be removed from the suite table? How will those entries be removed from the suite table? Choose two. Only removed from the network manager who's used. Maybe this is correct. Maybe. Let's see another one. The entry of the host for a host is removed if the host doesn't transmit any frame for a certain amount of time. So its time to read is expired. This is correct. They remain in the suite forever. Number C is wrong, clearly wrong, right? Number D, a table entry for a host will be removed by STPP, which will be used by a host, to signal the suite. So actually, I would check these two. I don't know which one is correct. Maybe we will reach in the book. I will check A or D. A or D, maybe one of the answer is correct. I don't know. Do you have any comment for this question? Do you have any answer for this question? Okay, let's go to the next one. So before the problem one here, let's solve for problem two. Problem two. I will check for the answer of the question number 13 and give to you the correct answer later. Okay. This question we has answered previously, actually. Consider the figure below. The IP and MAC address are shown for the node ABCD as well as the router interfaces. So in this figure, we have three network segments. All of the segments connect to a router. Okay, so router is the device that segmented the network into multiple network segments. Each segment has one subnet, right? The segment is also called the broadcast domain. So this is a broadcast domain. Okay. So consider IP datagram. Consider an IP datagram sent from B to A. B, it is a source to A. destination. Okay. So what are the source and destination MAC address at point number 3? At point number 3, which is this point. This point. Okay. Okay. This point. The source MAC address is the number A. Source MAC address is the MAC address of source MAC is the, so from B to A, so source MAC address is MAC address of B MAC address. Okay. Destination MAC will be the router MAC address, right? Router MAC address, which is the MAC address of this interface. This interface, right? Of 92 AF, right? 92 AF, right? The B MAC address is A5, this one, okay? A5 5B, 5B, right? Point number B. What is the source and destination IP address at point number 3? So IP address, it doesn't change. They doesn't change during the delivery. So the IP address source IP is the B IP, because sent from B to A, BIP, BIP address, which is 115, right? Destination IP will be the A IP address, okay? Address, okay? Which is the 17, right? 17. Right. And number C, source and destination MAC address at point number 2. Point number 2, which is this point. So at this point number 2, the MAC address change, but IP doesn't change, right? IP address doesn't change, but source MAC address source MAC address will be the MAC address of the router interface, router, which is this MAC address, right? E999, right? Is that clear? Any question? And the destination MAC address is the A MAC address, right? Which is the 4595, right? 4595, right? Is that clear? Any question? For example, if we have how about the traffic from A to C? How about from A to C? How about from A for the data RAM to C? With the same question, but how about the data RAM from A to C? A, so now A is a source, to C is the destination. Yeah. Okay, A is the destination. A to C, right? For example, at the point number 1, the point number 1 and 2, Okay. The source MAC address is what? Source MAC of the frame is the A MAC address, right? A MAC address, which is the 4595, right? Right? Destination MAC address will be the MAC address of the router, MAC address of the router, right? Which is the MAC address of the router, which is D9 99, which is MAC address of the router, right? At the point, so A to C, right? A to C. So for example, at the point 4 or 5 or 6, 4, 5 or 6, 4, 5 or 6, okay? Right? The source MAC will be what? Source MAC address is the MAC address of the router. This D, which is this one, right? This D, right? 92. And destination MAC will be the MAC address of B MAC address, right? B MAC address. IP address doesn't change. IP source, IP address is the IP, right? And the destination IP address is the C IP, right? Actually, this is the C, right? Yeah, C is IP address, right? Is that clear? Any question? Any question? I will check this question again. Okay? Check this question again. How about this one? This problem. Calculate the CSC, CSC of the of this data, or this data. Okay. So data here we have generator. This is the answer. Okay. So with the G generator equal to 0, 0, 1, 0, 0, 1, right? So we have 4 bits, right? So the number of bits is R plus 1. So we have R equal to 3, right? 4 bits. So this is the I equal to 3. So we choose 3 bits. The CSC field has 3 bits, right? Let's write out the payload D, but multiply with 2 to the R. 2 to the R, which is in this case R equal to 3, right? So it is 1 0 0 1 1 1 0 1, right? Add in 3 more 0 here, right? This is D multiply with 2 to the R, right? Right. So let's perform the XOR operator. Right? XOR operator. So let's using XOR is 1 0 0 1 XOR. Right? Is equal to 0 0 0 0. Right? And we append one more. Right? So it is 1 1 0 1. Right? So it is perform the XOR operator with 1 here. We have it is 0 1 0 0, right? So it's all 1 0 here, 0 here. So perform the XOR operator. XOR. This is the 0 0 0 1, right? And it's more 2 more here, right? So we have R is this one. This is the R, right? So R, the CIC equal to 1 0 0 because we need 3 bits, right? Is there any question about this one? Is there any question about this calculation? So we have this question in the final exam. Okay, a similar question. This similar question in the final exam. We also have a similar question like this question. The question that asks you to perform the extra calculate the extra shortest path algorithm. So the calculate the table, extra table. You create the table, and then you perform the you calculate the shortest path tree, and then find in the forwarding table. Okay, find in the forwarding table. So let's do this. Let's answer this question. Let's everybody. Let's do this question in 5 minutes before I give solution. Okay, just 5 minutes. So let's review the method and let's do it in 5 minutes. And after that I give you solution. Okay? So it start. Let's here it start from x, right? So let's root is x, right? But at home you can recompute with the same graph, but you can recompute it from with the root is u or w or b, etc. Any root, right? To redo the problem, right? So let's calculate this extra. Follow calculate the extra algorithm. So let's do it in 10 minutes. 5 or 10, 10, 5. I think that 5 is enough. It is n prime. So let's calculate the algorithm. Okay. So I use the table like this one. You answer, right? I use the table as they follow the book, the way the calculation as in the book. Okay. So here initially I use is initially is right? Is in the empire and y. So its neighbors of its is y, which is the 6. The distance to y is 6, with predecessor is y. Predecessor is um, connect to x, right? V is 3. Predecessor v is 3. Predecessor is this, and w is 6. Predecessor also is, and z is a. Predecessor is right on another is infinity, right? Infinity. And let's choose the smallest one, right? Smallest one. Let's choose this one, right? So V. So what is the neighbors of V? So we use the formula neighbor V on the other neighbors of V V. Okay, these neighbors of V are many, right? 5. X is already in n prime. So here is x, and we add v to n prime, right? X and v. Neighbors of v is y, w, u, and t. W, u, and t, right? So let's consider. Let's go to let's go to y but through v. Let's go to y but through v. So let's consider dy. Compare dy and current dy and dy but through v. Dy uh, we find the minimums of dy and d dy but through v. So it is dv plus cos of v y, right? Cos of vy. We find the minimum, right? Right? dv and cos of vy. So what is dv? dv is 3 cos of vy. Cos of vy is 8. So this is 11, but currently dy is 6. So here is remaining y is go directly to 6, right? Right? Any question? So now let's consider w. W, right? So we compare dw and go to w but through v. So now dv is 3, vw is 4. So this is 7. dw currently is 6. So 6 is still better than. So we remain in 6, right? Is it clear? Any question? How about you? Now you, VU, right? U and DU. Currently, DU is infinity, right? Infinity. DV is 3. CUV. CUV is CUV is 3, right? CUV is 3. Then this is 6, right? So we update this is U is 6, but and through V, right? 6 through V. Go through V, right? Go via V. Is that clear? How about T? T. T. T is T. VT. This is T. So VT. VT. VT is 4. Currently T is on DT is also infinity. So it is 7. 7 go through 7 go through V. Right? Remaining is stay the same. A is right. So this is the second step. Next step we have 6 is right. 6 we have 6 values. So we choose the first one. Add to the n prime, right? So here is V and Y, right? V and Y. What is the neighbors of Y? What are the neighbors of Y? Neighbors of Y is Z and T. Z and T, right? B and S are already in n consider in n prime, right? So Z and T. So now here's a Y. Let's see Y and Z, right? DZ. Go through. Go to Z via Y. Let's go to Z via Y. Vy is 6, right? CYZ, YZ, CYZ, YZ equal to, YZ equal to 12, right? 12, so it is the 19, right? 19. How about current DZ? Current DZ is A. So clearly A is the better. A is still keep A is better, right? Now how about T? T go to T via Y. Let's consider go to T via Y. So cos of the length YT is 7, right? So 6 plus 7 is 13. 13. How about DT? DT currently is 7. 7. 7 is better, so we don't change. Right? Don't change. So here still 6 B same 6 is the same. Right? Is that clear? Next step. Let's choose 6B. 6B is mean that we choose is V, Y, and we next step we add U to n prime. Right? We add U to n prime. U n prime. Right? So what are the neighbors of U? Neighbors of U include U here. Neighbors of U include T and W. T and W, right? W and T, right? U is W and T. V already consider, right? Already in n prime. So remaining node is W and T. So let's consider neighbors of U. Neighbors of U. So let's consider go to W via U, right? Go to W via U. DW, right? Via U. What is DW currently? DW currently is 6. Go through it. DU is 6. Right? DU is 6. UW is 3. So this is 9. But 6 is still smaller, right? 6 is still smaller, and you keep set is here, right? If this is a 10, if this one is 10, then we use the new part, right? The part go through U is better. But now it's 6, 6 is smaller. Right? How about T? T is T, go to T, but through U. Go to T through U. So UT is cos of UT is 2, right? How about DT? DT is 7. DT currently is 7, right? DT is 7, which is 7 is smaller than 8, right? So we keep 7 here. We go, right? Right? Here. And here is 8 is still the same. Okay. Next, choosing 6x, right? Choosing W is mean that choose W, put to the and right. Right. So is V, Y, U, and W, right? So now what are the neighbors of W? Neighbors of W is U. U already. W is SB and U. SBU already considered. So we doesn't update anything. Here still A is still 7V, right? Because all of the neighbors of W already considered, already in enterprise. Is that clear? Let's consider put T in enterprise, right? Look at T is V, Y, U, W, and T. So what are the neighbors of T? Neighbors of T are Y, V, and U. Y, V, and U. Y, V, and U. Already consider, right? Already consider. So here we don't update anything here. A is, right? Already consider, right? But on the neighbors of Lily already consider. So here is still A is, and then is, and the last one is the A is, put Z, and then we finish, right? V, Y, U, W, T, and Z, right? And we finish, right? Right. So let's plot the shorted path tree. Okay, shorted path tree. So it's connecting to go to Y. We go through X, Y through X. Here is shorted path tree. Okay. Okay. The second column, go to Z through X. Go to Z through X. This one, right? This is the third column, go to U through V. go to U through through V. Yeah, this is right. The next column go to V through X. Here this one. Okay. The next column go to X through, go to W, go to the next column, go to W through X, go to W through X. Yeah. Right. The last column go to T via V, go to T via V. Go here. So this is a shorted path tree. Right. So let's plot the forwarding table. The next is forwarding table. Okay. So in the forwarding table with the root is X. Remember, root is X. Okay. With the root is all the nodes, then we have different forwarding table. You remember, root is X. Based on this calculation, we calculate the shortest path with the root is X, right? So here is the go to the, this is the outgoing link. This is the destination. This is the out link, outgoing link. Okay. So with the destination is y is outgoing link is xy, right? Destination is v is v, right? Outgoing link. Destination is z, outgoing link is z. Destination is w, outgoing link is w. Destination is u, outgoing link is XB, right? Destination is T, outgoing link is also XB. That is the forwarding table. The root is X, right? Root is X, right? Is there any question? Now the one question, one more question, one more problem, one more types of problem in the final exam is IP subnetting. Huh? You know, so at home you can redo this problem with a different root, right? For example, you can redo this problem with the root is T, or root is U, or W, or Z, etc. You redo. Let's redo the problem with three parts: forming the table like this one, and table discharge calculation. They will perform the discharge calculation step by step like this one, and then plot the shorted path tree, and then the forwarding table. Okay. Now IP subnetting, let's see an example. Let's given the example is given, given the IP range is 10.0.0.0. The range is 16. So the range is 16 bit as the host. So let's subnet provide what the list the first, for example, 3 subnet. Okay, with each subnet has support more than, for example, I don't know, but maybe for example 4,000 IP. For example, we have this problem. Okay, that's this first 3 subnets. So let's do this problem. Okay. So from this condition, okay, this condition. So how many host bit per subnet? How numbers of what is the number of host bit per subnet equal to what is the number of host bit per subnet? Is there any answer? Is there any answer? Is there any answer? The number of host bit per subnet. So we know that due to the 210 due to the 12, right, equal to due to the 11 go to by 2 to the 10 20 48, right, 48, right, 2 to the 12 equal to 4 by 8, which is equal to 496, right? 1496, which is satisfy this constraint. So we choose the 12 bit. Okay, 12 bits, right? So given the range is 16, the subnet mask is will be The mask will be 32 minus 12 equal to 20. Right? So sudden mass is not 20. Right? So we have 20 1 bit A right, and then 1 1 1 1, and then 0 0 0 0 dot 0 0 0 0, right? So this is a bit, right? So the separating is here, right? Separating is here. The subnet mask. What is the subnet mask here? 255, 255. Bits. This is 4 bit. 4 bit. So here A plus A is 16. 16 plus 4 is 20. So the subnet mass is like this one, right? 2 body, right? Log 0. This is a subnet mask for all the subnets, right? And given the this is a 16, so we fix the first 2 bytes and the subnet bits is like this one. This is a subnet bit with the bit utilizing from the host as the net, right? Check 4 bits. We borrow 4 bits in the host to become the net, right? So let's write down the for the subnet bit is 0. Subnet bit right? 4 bit, right? So here the first subnet, right? The subnet bit is we use the subnet bit is 0 0 0 0. Subnet bit. Subnet bit is 0 0 0. Okay, as the subnet bit. So the net is what? The net is 10. This is doesn't change. It doesn't change. The first 2 bytes. But the next byte, the third byte is 0 0 0 0, right? Zero, 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 dot, bit 0, right? So the subnet here is range from here to 1, 1, 1, 1, dot 255, right? So the subnet address equal to 10, dot 0, dot 0, dot 0. The first, the subnet address, this is the subnet address. This is the broadcast address of this subnet, right? Of the first subnet, right? Address, broadcast address, right? I have broadcast is 10 dot 0 dot 0 0 0 0 1 1 1. So it is 15 dot 255. Remember the subnet mask, all of them have the subnet mask. This is a subnet mask. Okay? This is a subnet mask. for every subnet. Every subnet. Okay. Is that clear? And the valid host will be from 10.0.0.0 to 10.0.15 of 254. Right? All right. Any question? Any question? The second subnet. Okay. So the second subnet is using the 0001 as the subnet bit. Okay. Okay. So it is 10.0.0001 at the subnet bits. Okay, let's go from 001 000 dot bit 0 in decimal to 1111 dot 255 in decimal. Right? So similarly, we have this is a network subnet address. Okay, this is a broadcast address for this subnet, for the second subnet. Okay, for the second subnet. Okay, so the subnet address will be 10.0.16.0. Remember, it is a part 20, right? Is a 7 mask. All of them are 20, right? 7 mask. Okay. And the broadcast address will be 10.0, the last one, right? The last one. Okay. So 16, but now it's not 16. This is a 31.255. And the valid range of this subnet will be 10.0.16.1 to 10.0.31.254. 20. Right? The second subnet, and similarly for the third subnet, you can write out third, fourth, five subnet, etc. Right? Third subnet. So using 0000010 at the subnet bit. Okay. So it is the first number is 10.0 0010. 0000 dot big 0 and 00101111 dot 255. Right? We don't need to rewrite this one. Right? So this is a subnet address, right? This is a broadcast Right. Similarly, we have subnet will be 10.0. Oh, what is this one? This is 32.0, right? 20 broadcast. $10.0. This is the 32 plus 32 plus 15 is 47, right? Am I correct? Hmm? 255. Hmm? 20. So the valid cost will be from 10.0.32.1 to 10.0.47.254. All of them have subnet mask is 20, 20, which is this subnet mask. Okay, 20. This subnet mask. Right. So that's all. Right. Is there any question? Mm, you know, so can you see the topic we will cover in the final exam? Okay. I don't know, it's too small, but I cannot zoom out. So this is the topic we will cover in the final exam. Okay, we transport layer, TCP congestion control, congestion control. The number of chapter 4 is network layer overview. 4.1, 4.3 is IP. In IP here also include DHCP and DHCP and IP subnetting, right? Maybe in IP subnetting is also included in 4.3. 4.4 generalized forwarding, right? Well, generalized forwarding table. Chapter number 5, introduction, control plane related to routing, routing protocols. So routing algorithms, intra-routing, like OSPF, link state, distance vector, all of them are intra-routing. First, you study the principle of link state algorithm and distance vector algorithms, and then one particular protocol is OSPF, which use link state algorithm. Okay, and you have a brief knowing the SDN, just some brief description about SDN, software defined network, and ICMP. Remember DHCP, the protocol, the application used to provide the IP address automatically in the network is maybe considered inside the 4.3, which is Internet protocol. Number 6, link layer. You will study about link layer, introduction to link layer, like service of link layer. Number 6.4 is the error detection correction, particularly the properties of detection correction, and CIC, know how to calculate CIC. And then 6.3 is the multiple access link protocols like Aloha, slotted Aloha, CSMA CD. That is for sharing broadcast medium. And then we have channel partition, like PDMA, FDMA. And then we use another protocol like Polylink. Number 6.4 is we have studied about VLAN, MAC address, Ethernet, etc. VLAN, routing between VLANs, etc. in the 6.4. That are the topics we will cover in the final exam. So final exam maybe include the multiple choice question. So include 2 sections, multiple choice questions and the problems. So multiple choice questions, choose only one answer for each question. So it's the score will be 60 to 70% of on the final exam, and the short answer question like calculating the CIC, calculating the shorted path, subnetting, right? Subnetting is in the short answer questions. Is that clear? Any questions about the final exam? Trần Thiên Phú. Trần Thiên Phú, you had the questions about subnetting. Trần Thiên Phú, subnetting. The first subnet, right, Thiên Phú? First subnet. Yeah, correct. Thank you, Thiên Phú. Any other comment? So the you know the question, the problem maybe including the CIC calculation, including the subnetting and the shorted path. Actually, we only have that 3 types of short answer of this the calculation problems, right? So the versions of shorted path given here is quite simple. So we don't have any change in during the calculation, right? So it's just very straightforward. You can practice at home with using another root, like let's consider root from U or W, right? So to see if, so let's fluent with, familiar with the calculation with the different root. The version we consider here is quite straightforward, where we don't have any changing during the of the predecessor during the delivery. Okay? During the calculation. Sorry, this is a predecessor. Predecessor. P is P. This is a dy. Py. dz. pz. du. pu. pv. pv. pw. pw. And pt. pt. That is the correct label. D is the distance. P is the predecessor. D is the distance. P stands for D. I don't know if I pronounce correctly. Predecessor. Predecessor. Let me check. Predecessor. Predecessor. This is more correct. Predecessor. Any other question? Okay, so if you don't have any question, we stop here. I will reconsider. Is there someone happy to search for the answer of the number 13? Number 13. What is the correct? A or D? A or D? Which one is correct? Answer. Just read the book, right? And which one? Anyone have the answer? I haven't searched, right? Which one is the correct answer? A or D? Number 13. A or D? Anyone have answer? I think D is better. I will check, right? Anyone has checked for the answer of this question? Maybe D. I think that may be D. Okay, I will send to you the answer for the today answer. And also this answer. Okay. I think that if you don't have any other question, then we stop here. Okay, so try. You you are allowed to print 2 page handwritten note. 2 page handwritten note to the exam room. So we have around 30 to 40 multiple choice questions and maybe 3 short answer questions. 3 or 4 short answer questions. Trong Thuần has recorded the today lecture, so please share to your friend, share to on class the recording. Okay, we stop here. So.